In this video, we're going to talk about naming alkanes with simple substituents. That means we're going to introduce the concept of IUPAC nomenclature and just go over a few simple examples. Nomenclature is a system of names or terms. What we use in chemistry is the system that's established by IUPAC, or the International Union of Pure and Applied Chemistry. The IUPAC system is the standard for naming chemicals, both organic and inorganic, so we're going to learn their system. You'll see that many organic compounds are also referred to by trivial or common names, and I'll let you know what those are, but you don't have to know those. Really, what I'm going to test you on is the IUPAC nomenclature. Here's our general approach to naming organic molecules. First, you need to determine the suffix, and that depends on what type of molecule you're looking at. In this chapter, all we're going to cover is just regular alkanes, and alkanes have the suffix ane. So everything that we're going to cover in this chapter is going to end with ane. Once we start looking at naming molecules that have suffix-changing functional groups, then we will have to worry about different suffixes. But for right now, they're all going to be ane. Next, you have to determine the parent chain. The parent chain is the longest chain in the molecule. Once you have identified the longest chain, you can use that longest chain to determine the prefix. The prefix is associated with the number of carbons in the parent chain. The prefix and the suffix together then give the root name. If you don't have anything attached to your parent chain, then you're done at this point. However, if you do have things attached, and most times you will, you're going to have to name those groups, and those are called substituents. A substituent refers to any group attached to that main parent chain. Next, we're going to number the parent chain so that the first substituent has the lowest possible number. In the future, we'll also have to worry about this or most important part here, but you don't have to worry about that for now. Once you've numbered the parent chain, then you can number each substituent as shown in step 7. You're going to give each substituent a number in front of the name of the substituent and put a hyphen between them. Then all you have to do is order everything alphabetically, combine, and then you're done. We're going to walk through several examples of how to go through this process. As I mentioned, alkanes have the suffix ane. That means a molecule with 2 carbons becomes ethane. A molecule with 3 carbons is propane, and so on. A lot of these make sense. For example, pentane, the pent prefix is associated with pentagram or pentagon. The hex prefix is also associated with hexagon, so hopefully you can remember those. The tricky ones are these first few, meth, eth, prop, and bute. My weird trick for remembering them is going my eyes pee blue. It's kind of silly, but it works. Now, if any of these groups are a substituent, then we change the suffix to YL. For example, if I were to have a molecule here, the parent chain is 1, 2, 3, 4, 5 carbons long, which makes it a pentane, and my substituent here, hanging off the main parent chain, is 1 carbon, so it becomes a methyl group. Here's a little bit more information on substituents and parent chains. Substituents, of course, are those atoms or groups of atoms that are attached to the main parent chain. Essentially, what they're doing is replacing a hydrogen. You can see a substituent group here, here, and here. The parent chain, or often referred to as the main chain, is the longest continuous chain of carbons. It doesn't matter how the molecule is drawn, you're just looking for the longest continuous chain. In this first example here, 1, 2, 3, 4, 5, 6 carbons is not the longest chain. You have to count down. 1, 2, 3, 4, 5, 6, 7. Here we have a substituent. It's 2 carbons in length, so it becomes an ethyl substituent. Now let's look at this example on the right. We have 1, 2, 3, 4, 5, 6, 7, 8 carbons. But if we go this way, we also have 1, 2, 3, 4, 5, 6, 7, 8 carbons. So what do we use to break the tie? There are a couple of rules that you want to think about if 2 or more chains have identical length. One way to look at this is to look at which chain has more substituents. The one with more substituents wins. In this case, we have the same number of substituents no matter which chain we use, so we actually have to use another tiebreaker. And we're basically going to look for the one that gives the simplest possible name. That means we want to avoid parentheses, and we'll get to that in a little bit. Our substituents here are methyl, and this 3 carbon chain over here is propyl. What do we do when we have multiple identical substituents? Let's look at an example. In this case, I have a methyl group here and another methyl group here. If I'm naming this molecule, I'm going to first number to give the first substituent the lowest possible number. That puts the 2 on the first methyl group and a 3 on the second. I'm going to combine those numbers in order. 2 and 3, separate each with a comma, and then add the appropriate prefix. In this case, I have 2, so it's going to be di. That means I would say that my substituents are 2, 3 dimethyl. In this case, I have a 5-carbon chain, and that would make it a pentane. These prefixes here, the di, tri, and the tetra, don't count in terms of alphabetical ordering. So for example, if I had an ethyl group somewhere else in my molecule, the ethyl would come before the methyl in the naming. We just ignore the di. Let's look at some examples. First, we're going to determine the suffix. This is an alkane, so the suffix is ane. Next, we need to determine the parent chain. The parent chain is going to be this longest chain right here. I'm going to circle that in pink. Next, we're going to go through and determine our prefix to get our root name. 1, 2, 3, 4, 5, 6, 7 gives us heptane as our root name. Prefix is hept, suffix is ane. Next, we need to name our substituents. We have an ethyl group over here, and we have a methyl group over here. Now we need to number our parent chain. If we number starting at this end, 1, 2, 3, 4, we have our first substituent at 4. If we number from the other end, 1, 2, 3, we get our first substituent at 3. We want to number to give substituents lower numbers, so we're going to number from the top here, 1, 2, 3, and put our methyl group at position 3. If we keep numbering, that means that our ethyl group is at position 4. Now we have to alphabetically order everything. Ethyl comes before methyl, so that will give us 4 ethyl, 3 methyl, heptane. Let's look at our next example here. Our parent chain is going to go through here. You see here we have a choice. We can go up or we can go down. Either way is the same number of carbons, so it really doesn't matter. So there's our parent chain in pink. Let's name our substituents. Here we have an ethyl group, and then we have 2 methyl groups. Now we have to number. If we number from the right, we get a substituent at 1, 2, 3. If we number from the left, we get a substituent at 1, 2, 3. So how are we going to number this? In this case, we'll use the middle methyl group to break the tie and number to give it the lower number. In the case where you still have a tie, we can use alphabetical order as a last resort. Okay, that means that we have a 3 ethyl, and then we have a 4, 7 dimethyl, because there's 2 of them, nonane. Let's do our last example here. In this case, we have our parent chain here, and we have 1, 2, 3 methyl groups. We're going to number to give substituents the lowest possible numbers. If we number from the left, 1, 2, we have 2 substituents. If we number from the right, 1, 2, we only have 1. So we want to number from the left. 1, 2, 3, 4, 5. That gives us 2, 2, 4 trimethyl pentane. That wraps up this first video. We're going to look at more complicated examples of naming alkanes in the next video.